In section 4 of module 4, we're going to talk about some properties of quadratics. So the first thing we're going to talk about is a few definitions. So a parabola, which you've probably heard before, is just the graph of a quadratic. So they specifically call the shape of a quadratic a parabola. So just kind of remember the equation for a quadratic, y equals ax squared plus bx plus c. We also have something called a vertex, which is the bottom, which is the minimum, or top, which is the maximum of the parabola. And the nice thing about the vertex is that the x-coordinate of the vertex is always x equals negative b over 2a. So no matter what equation you're given for a quadratic, you don't have to graph it to find the vertex. You can find the x-coordinate using this formula and then plug that in to find the y-coordinate. And then we have something called the axis of symmetry. So the axis of symmetry is a vertical line that splits the parabola in half. Now the nice thing is that vertical line always goes through the x value of the vertex, because the vertex is, since it's that minimum or maximum point of your quadratic, it tells you where it gets split in half. So we use the equation x equals negative b over 2a, just like we do when we find the x value of our vertex. All right, so let's talk about how we can graph quadratics based on the form it is already in. So we have the equation y equals x squared plus 2x minus 1. So our equation is currently in standard form. So that's just the general form for a quadratic. So the way I want to graph it is using a table of values. And I want to make sure I pick my table of values strategically. I want to pick very specific points. And the way I'm going to pick those points is based off where my vertex is. So the first thing I'm going to do is I'm going to find my vertex. So I'm going to use x equals negative b over 2a to find the x value of my vertex. So b is 2, so I'm going to do negative 2 over 2 times a, which is 1, which is going to be negative 2 over 2, which tells me the x value of my vertex is at negative 1, which is also my axis of symmetry. So I'm going to go ahead and label that in my graph. So negative 1, I'm going to draw my axis of symmetry, which is a line. Okay. Now, when I go to create my table, my x and y values, I want my vertex to be my middle point, and I'm going to pick 2 points below that, so negative 2 and negative 3, and I'm going to pick 2 points above that, 0 and 1. Now all I do is I plug in those x values into my equation. So I'm going to do negative 3 in parentheses squared plus 2 times negative 3 minus 1. And it gives me a y value of 2. Now I'm going to do the same thing with negative 2. So I'm going to do negative 2 in parentheses squared plus 2 times negative 2 minus 1. Gives me negative 1. Now I'm going to do negative 1 in parentheses squared plus 2 times negative 1 minus 1, which gives me negative 2. The nice thing is here, when I plug in 0, 0 squared is 0, 2 times 0 is 0, so I'm just left with negative 1. And then 1 squared is 1, 2 times 1 is 2, So 1 plus 2 is 3, minus 1 is 2. So if you notice here, once you hit that vertex, the points start repeating, which is nice. So I'm going to start with my vertex at -1, -2. Then I'm going to graph -2, -1, and then -3, 2. I'm going to repeat. I'm going to do 0, -1, and then 1, 2. I'm going to connect those points. And I have the graph of my quadratic. It is important here that when I was plugging in my negative values for x, I did put parentheses around them in the calculator. Because if you don't put them in parentheses, especially when you square them, you're not going to get the correct answer. -3 in parentheses squared is not the same thing as -3 without the parentheses squared. So it's very, very important that you remember parentheses. So now let's answer a few questions about my quadratic. So the first question I want to know is, does my graph open up or down? And it does open up. Okay. The next thing I want to know is, where is my vertex, which we already calculated. It's at -1, -2. And then our axis of symmetry, which we found is always the x value of my vertex, x equals -1. Now, what if I don't already have the graph? So now I have the equation y equals -3 x squared minus 6x plus 3, which I haven't already graphed. But I want to know if it opens up or down, where its vertex is, and where its axis of symmetry is, but I don't want to go ahead and graph it because that's a lot of extra work. So the nice thing is you can determine what direction a parabola opens based on the sign of a. So whatever the sign of the number in front of x squared is tells you what direction it opens. And if a is positive, it opens up. And if a is negative, it opens down. So in this case, a is -3. So my parabola is going to open down. To find my vertex, I'm going to use my formula for my x value. So I'm going to do -b, which b is already negative, so it's -6, over 2 times a, which is -3. So -6 becomes 6. 2 times -3 is -6, which means I get an x value of -1. So to find my y value, I'm going to plug that into my equation. I'm going to do -3 times -1 squared minus 6 times -1 plus 3. And that is going to give me my y value. Which is 6. So my vertex is at -1, 6. And then for my axis of symmetry, it's always the x value of my vertex, so x equals -1. It is very important that when you are writing the axis of symmetry, you include x equals, because the axis of symmetry is a line, it's not just a number. So it's extremely important that you write it as x equals. Next that we're going to look at is another form called vertex form. And the nice thing about vertex form is that it identifies the vertex for us directly in that form. So I don't have to go through all of that extra work of using that formula -b over 2a to find the x value, then plugging it in to find the y value. It's also a little bit easier to create our table of values in order to graph it. So we'll start by identifying our vertex. So when you're identifying the vertex from vertex form, a couple important things here. The x value is always the opposite of what's inside that parentheses. So if we're looking at vertex form, we have y equals a, parentheses x minus h squared plus k. And my vertex is hk. So since h is written as in the parentheses as minus, that actually tells me that when it's a minus, it's a positive x value. And when it's a plus, that means it has to be a negative. because the vertex kind of works to say, what do I have to do to get back to 0? So if I have x plus 1 squared in parentheses, my x value is actually going to be -1. Now the nice thing is the y value keeps its sign. So that -2 is going to stay a -2. So when I create my table of values, I'm going to do -3, -2, -1, 0, and 1. I already know my vertex, -1, -2. It's also a little bit easier to plug in points. So now I'm going to do -3 plus 1 in parentheses squared -2, and I'm going to get 2. Then I do -2 plus 1 in parentheses squared -2. I get -1, which means these then repeat. So you can see that this is the exact same equation that we graphed in our first example. It's just now written in a different form. So my axis of symmetry is still at -1. If I plot my points, I have -1, -2, -2, -1, -3, 2, 0, -1, and 1, 2. So no matter which form I use, standard form or vertex form, I can get the exact same graph. And it's probably a little bit easier to graph in a quadratic if it's in vertex form. So let's go ahead and, based on vertex form, answer the exact same questions. So for my equation, y equals x plus 1 squared minus 2, it opens up. The nice thing is the vertex, -1, -2, and my axis of symmetry, x equals -1. Now let's look at a different example. Y equals -x minus 4 squared plus 7. So a is still here, it just is in front of the parentheses instead of in front of the x squared term. So again, if a is positive, it opens up, and if a is negative, it opens down. So we have a negative in front of our parentheses, so it opens down. For the vertex, it's going to be at 4, 7. And then for my axis of symmetry, we'll have x equals 4. So much nicer to identify the vertex as an axis of symmetry from vertex form. Up or down, just as easy no matter which form you're in, whether it's standard form or vertex form. So the last thing we're going to do is talk about how do we go from standard form to vertex form. You can identify the vertex using the formula, the x equals -b over 2a, then you can plug it in and then you can convert it that way, but that's very time consuming. There is another method, and it uses completing the square. It's not the exact same process of completing the square, it's just a little bit of the same. So the first thing we want to do, so if we have y equals x squared plus 2x minus 7, is I kind of want to put the x's in their own little set of parentheses. So I have x squared plus 2x inside parentheses and then minus 7. The part that is similar to the completing the square is I now want to find b divided by 2 squared. I want to do that b divided by 2 squared part. That's what the part from completing the square that we're going to use. So in this case, b is 2. We're going to divide it by 2, and we're going to square it. So 2 divided by 2 is 1. 1 squared is 1. So what we're going to do is we are going to put that plus 1 inside my parentheses. Now, if I put that plus 1 inside my parentheses, I still have my minus 7 on the outside. If I drop those parentheses, I want to be able to get back to my original equation, which means if I have a plus 1 in the parentheses, I have to have a minus 1 outside the parentheses. Now, the quadratic that I have in my parentheses is a perfect square. So x squared plus 2x plus 1 is going to factor as x plus 1 squared. And then I do -7 minus 1, and it gives me -8. So I have the equation y equals x plus 1 squared minus 8. And that is the vertex form of my equation. Now, similar to when we did completing the square, I can really only use this method if the number in front of my x squared term is 1. Otherwise, I have to do a little bit more work in order to convert it to vertex form. So we're doing one more example. So we have y equals x squared plus 6x minus 8. So I'm going to go ahead and put my x squared plus 6x in parentheses with my minus 8 on the outside. Go ahead and do my 6 divided by 2 and then square it, which is 3, which gives us 9. So we're going to have x squared plus 6x plus 9 in parentheses, and the minus 8 minus 9 outside of our parentheses. When I factor x squared plus 6x plus 9, we get x plus 3 squared, and then negative 8 minus 9 is negative 17. So let me know if you have any questions about graphing quadratics, whether it's in standard form or vertex form, identifying the vertex or axis of symmetry using that formula, opening direction, or of course converting between standard form and vertex form.